now our next topic that is extensive and intensive properties. Okay, this is very simple to remember. There are two types of properties, whether you say that is volume, mass, density, pressure, etc. etc. Okay, so there are different properties, and these properties can be divided into the two parts, that is extensive property and intensive property. Okay, so what is this extensive property and intensive property? Extensive means you need to remember which depends on the number. Any of the thing which is having a numerical values, okay, depending upon the number or the quantity we can say. Okay, if quantity increases, okay, if quantity increases, then the property increases or decreases, then their type of properties will be extensive properties. Okay, and second is intensive property. The properties which do not increase or decrease with increase or decrease of the material. Okay, so like for example, if you are taking ice, okay, if you are taking ice, so if you are taking 5 gram of ice, so mass 5 gram of ice and 10 gram of ice. So what we say, the volume is different, the mass is different, the internal energy will increase or decrease, etc. But 5 kg or 5 gram of ice will have the same temperature, उसका boiling point और melting point तो same रहने वाला है, right? That is the melting point of ice will be same for 5 gram of ice also, and for 100 gram of ice also, or for 100 kg of ice also. Okay, so pressure, density, all these things are what? They won't change with increase or decrease in the quantity of the material or the matter. Okay, so when the properties which are not changing with increase or decrease of the quantity, those properties are known as intensive properties. But the properties which changes with the quantity, अगर quantity increase और decrease होगा तो उसका उसकी अगर properties change होने वाली है तो वो कौन सी properties होगी? That is extensive properties. Okay, so mass, volume, internal energy, etc. are intensive property, while temperature, density, pressure, etc. are intensive property. Okay, again I'm going to explain this. The quantity, with the change of the quantity, if the property changes, then they are known as extensive property. But with the change of the quantity or size, if the property does not changes, then they are what type of quantities? They properties, they are intensive properties. Okay, so let us go with the definition. And extensive property is the property whose value depends upon the quantity or size of a matter present in the system. Example, mass, volume, internal energy, etc. Okay. Next, an intensive property is the property whose value does not depend upon the temperature, that is, does not depend upon the quantity or size. Okay, and the examples are temperature, density, pressure, etc. Okay, the molar property is value of a extensive property X of a substance, 1 mole of a substance. Okay, so when we are having an extensive properties, okay, like mass, volume, internal energy, etc. Okay, so कोई भी मैटर अगर हम ले रहे हैं उसका 1 mole of property जो भी होगा of the extensive property is known as the molar property. Okay, is known as the molar property. If n is the amount of matter, then that is xm is equals to x upon s is independent of the amount of matter. Okay, if n is the amount of matter, okay, so amount of matter, first of all, what see we have seen, that is molar property. Molar property means what? The extensive property, कोई भी extensive property होगी x of a system of 1 mole of a substance. अगर हम 1 mole of a substance ले रहे हैं, then it will be having what type of property? 1 molar property. That is 1 mole of substance having mass, 1 mole of substance having volume, 1 mole of substance having internal energy. Okay, 1 mole of NaOH is having mass of this much. 1 mole of NaOH is having volume of this much. 1 mole of NaOH is having internal property, internal energy of this much. Okay, so at that time, this much amount is nothing but the property, that is molar property. But if we are having different amount of matters, so that's why we are considering what? If n is the amount of matter, then molar, that is xm is equals to x upon n. ठीक है, 1 मोल का that is definite, that is xm. बट अगर हम नंबर ऑफ मोल्स इंक्रीज कर रहे हैं, अमाउंट इंक्रीज कर रहे हैं, तो हमें क्या करना पड़ता है? वी नीड टू डिवाइड बाय n. We need to divide by n, and this property is independent of the matter. This property is independent of the matter. Okay. Now we come to our next topic, that is heat capacity. We measure heat capacity by measure of transfer of heat. Okay, heat जितना ट्रांसफर होता है उसके बेसिस पे हम उसकी heat capacity measure करते हैं. The increase of temperature is proportional to the heat transfer. Definitely we know heat transfer means what? Heat energy जितना release हुआ है, that is what? Basically increase in the temperature. The increase in the temperature is proportional to the heat transferred. ओके, उसके अंदर हीट कहाँ से आया? ट्रांसफर होके आया है कहीं से, मतलब टेम्परेचर रेज होगा. टेम्परेचर कब रेज होगा? जब वहां पे कोई एक्स्ट्रा अमाउंट ऑफ हीट ऐड हुआ है तब. तो ये हीट क्या है? हीट इज ट्रांसफर्ड ओवर देयर. ओके, सो प्रोपोर्शनैलिटी कांस्टेंट की जगह पे हमने यहाँ पे क्या लिया है? कोएफिशिएंट. सो कितना हीट ट्रांसफर, जितना हीट ट्रांसफर हुआ है वो एक्चुअली क्या है? Change in the temperature. So that's why we say what? Q is equals to coefficient into delta T. Delta T means what? Increase in the temperature or change in the temperature. पहले 5 सेल्सियस था, अब 10 सेल्सियस हो गया है. तो कैसे हुआ? कुछ अमाउंट ऑफ एनर्जी, दैट इज कुछ अमाउंट ऑफ हीट उसके अंदर ऐड हुआ है, राइट? सो दैट अमाउंट ऑफ हीट इज एडेड and constant is coefficient, and we are having delta T, that is change in temperature, or we can say increase in temperature. The magnitude of the coefficient depends upon the size, composition and nature of the system. Okay, ये जो coefficient है वो किसके ऊपर डिपेंड करता है? अपना जो मैटर है उसका साइज, composition and nature. Okay, so this coefficient can also be written as C. Okay, where C is coefficient, C is known as the heat capacity. Okay, so that C constant is nothing but our coefficient, is nothing but our heat capacity. When C is large, the amount of heat given out result in very small rise in temperature. Again, when C is large, the amount of heat given out results a very little rise in temperature. Okay, अगर कोएफिशिएंट बड़ा है, अगर कोएफिशिएंट बड़ा है तो रेज इन टेम्परेचर छोटा है. अगर कोएफिशिएंट बड़ा है, दैट इज हीट कैपेसिटी इज बिगर. कैपेसिटी है ना वो, तो वो ज्यादा हीट एब्जॉर्ब करने की उसमें कैपेसिटी है, तो टेम्परेचर ज्यादा इंक्रीज नहीं होगा वहां पे. ओके, सो दोनों रेसिप्रोकल है. अगर ये ज्यादा है तो ये कम है. अगर सी ज्यादा तो डेल्टा टी विल बी लेस. If C is more, delta T will be less. Okay. Now C is directly proportional to the amount of substance. The molar heat of a substance. Again, molar की बात आ गई, that is number of moles. So we write down M. So Cm is equals to C upon N. तो N तो हम क्या लिखते हैं? अमाउंट ऑफ द सब्सटेंस. जैसे हमने आगे देखा था, राइट? यहाँ पे हमने देखा था ना, कोई भी क्वांटिटी है उसको हम उसकी मोलर प्रॉपर्टी डिवाइड बाय एन करते हैं. सो सेम वे ओवर हियर, अगर हम प्रॉपर्टी ये ले रहे हैं, दैट इज हीट कैपेसिटी. सो हीट कैपेसिटी सी एम ऑफ मोलर इज इक्वल्स टू सी अपॉन एन, दैट इज टोटल नंबर ऑफ मोल्स. Thus, specific heat capacity of a substance is equals to QCm into delta T. or we can say C delta T where M is remaining constant. क्यों ऐसा लिखा है M यहाँ पे? बिकॉज हम मोल्स यहाँ पे अगर चेंज करेंगे तो ये वैल्यू यहाँ पे मेंशन करनी पड़ेगी. ओके, नंबर ऑफ मोल्स वी आर मास वी आर सपोज टू सी, कौन सा मास हम ले रहे हैं. वाई? बिकॉज यहाँ पे क्या लिखा है? अमाउंट ऑफ द सब्सटेंस, राइट. सो अमाउंट ऑफ द सब्सटेंस के लिए व्हाट वी आर सपोज टू सी, स्पेसिफिक हीट, कोई भी स्पेसिफिक सब्सटेंस का हीट अगर हमें कैलकुलेट करना है, दैट इज Q इज इक्वल्स टू Cm into delta T, or we can say C delta T, that is one and the same. If we are writing C delta T, that is okay, but that should be having a constant value of mass. Now, this is one of the important topic and this can be asked in your examination point of view. So please be very careful. That is relation between Cp and Cv for an ideal gas. Okay, Cp and Cv for an ideal gas means what? Heat capacity at constant pressure and heat capacity at constant volume के दोनों के बीच में relation क्या है? Okay, so at constant volume, heat capacity C is denoted by Cv, and at constant pressure it is denoted by Cp. So the relation between them will be what? At constant volume, ये चीज ऑलरेडी हमने आगे देख चुकी है. कांस्टेंट अगर वॉल्यूम है तो Q is equals to Cv delta T. We know over here we have written Q is equals to C delta V. अभी हम यहाँ पे इस फॉर्मूला में क्या कर रहे हैं? We are keeping our V as constant, that is volume as constant. That's why we are writing QV is equals to CV delta T. But when we were discussing about free energy and heat, at that time we have seen if volume is constant, that is also equal to delta U, that is change in the free energy. Okay, और अगर pressure constant होता था तो क्या था? There was change in the enthalpy, right? That is delta H, right? So if we are keeping volume as constant, then our heat at constant volume is nothing but Cv delta T is equals to our change in free energy. Okay, और यहाँ पे Qp is equals to Cp delta T is equals to delta H. Okay, now the difference between Cp and Cv, that is Cv and Cp, can be derived in the ideal gas for 1 mole. Okay, so that we are going to see over here. For 1 mole of ideal gas, delta H is equals to delta U plus P delta PV. Okay, this is 1 molar equation. We know that delta H is equals to delta P plus this equation already we have discussed in our previous video. Okay, that is delta H is equals to delta U plus delta PV. डेल्टा पीवी हमने ऐसे क्यों लिखा है? क्योंकि अगर कोई भी चेंज होता है तो वी कैन यूज दिस डेल्टा. अब पीवी होता क्या है? पीवी इज इक्वल्स टू एनआरटी, वी नो. बट एनआरटी तो इसमें एन हमने नहीं लिखा. क्यों? बिकॉज इट इज ऑफ 1 मोल. सो एन विल बी 1. तो बच क्या जाता है? पीवी की जगह पे हम लोग क्या लिख सकते हैं? आरटी. दैट इज delta U plus delta RT. Okay, now R we know that it is constant. Okay, that is delta U is equals to R constant and delta T. R constant and delta T. Okay, therefore delta H value we are getting as what? Delta U plus R delta T. Delta H is equals to delta U plus R delta T. Now on substituting this value, what we get? Cp delta T is equals to Cv delta T plus RT. ये कहाँ से आया? See now, see over here. Delta H is equals to delta U plus RT. ये पता चल गया आपको? Yes. In previous slide what we have seen? Delta U is nothing but Cv delta T. Okay. So delta U की जगह पे हमने क्या लिख दिया? Cv delta T. Okay. और delta H की जगह पे हम क्या लिखेंगे? Delta H की जगह पे हम क्या लिखेंगे? Cp डेल्टा टी. ओके, सो हमारा इक्वेशन क्या बन जाता है? डेल्टा एच की जगह पे Cp डेल्टा V इज इक्वल्स टू Cv डेल्टा T प्लस RT ऑलरेडी है हमारे पास. ओके, सो नाउ हियर व्हेन यू सी इन दिस व्हाट यू कैन टेक आउट कॉमन. डेल्टा T कॉमन निकल गया और यहाँ पे भी डेल्टा T है. सो डेल्टा T विल बी कैंसल्ड. ओके, सो what we will get ultimately? We will get that Cp is equals to Cv plus R. What we are getting, ये cancel और ये cancel. Okay, that is बच क्या जाता है? Cp is equals to Cv plus R. Okay, so you can write down Cp is equals to Cv plus R, and also you can write down what? Cp minus Cv. This is on the positive side. This is positive. When it goes on the other side, it will become negative. Okay, so we are getting what? Cp minus Cv is equals to R. Cp minus Cv is equals to R. Okay, I'm explaining this again. This is very important, and I told you it can be asked in your examination. Okay, relationship between Cp and Cv. So अकॉर्डिंग टू दैट कांस्टेंट वॉल्यूम है अगर, तो हमने ऑलरेडी डिराइव कर लिया है क्यू वी इज इक्वल्स टू सी वी डेल्टा टी इज इक्वल्स टू डेल्टा क्यू. प्रेशर कांस्टेंट होगा एट कांस्टेंट प्रेशर Q is equals to Cp delta T is equals to delta H. Now, for 1 mole of an ideal gas, we can write down this delta H is equals to delta U plus P delta V. P delta V की जगह पे V और PV की जगह पे हम क्या लिख सकते हैं? RT, because ideal gas equation क्या है? PV is equals to nRT. But N we are taking as 1 mole, so we are not writing here. Okay, so now delta U plus R delta T. Why we have written this way? Because R is constant. Okay, so we are getting delta H is equals to delta U plus R delta T. Okay, so now putting these values of delta H and delta U, what we get? We get this equation, and from here we are cancelling the delta T. Okay, and that's why we are getting what? Cp is equals to Cv plus R. So Cp minus Cv is equals to R. Okay, thank you.